Okay, I want to take the antiderivative here, and I'm looking at this. I'm going, it kind of looks like an arcsecant, but not really, because if this is u, well, if u is e to the x, then I need a u out here. So let's just fit around with it. If I did a straight u substitution, let's see what kind of form we can get it in. So if I let u equal e to the x, then obviously that implies that du equals e to the x dx, which then implies that du over e to the x is actually equal to dx. Now, normally you'd do this and go, oh no, this is not going to work, because I need to replace dx with du, maybe times a constant, not times a function of x. I can't go from x's. I mean, this doesn't make much sense. There's a little bit of an issue here. Well, not really, because remember, u is e to the x. So du is actually u dx, or du over u. So this really gives me du over u equals dx. Now I have this function of u's. So this thing gives me the integral of 1 over u. I'm just going to write a 1 here and put the u down here, times the square root of, this is going to be u squared minus 1 du. Now this looks like arcsecant. When I say it looks like arcsecant, I'm talking it looks like the derivative of arcsecant of u. So this is actually going to be arcsecant of u plus c. But what was u? U was e to the x. So what my original solution is, the solution to my original problem, is going to be arcsecant of e to the x plus c. Now this next one, this looks like it should be a kind of a trig function, but don't get into, I'm sorry, an inverse trig function, but don't get into the routine of, well, I've had the square root of something with x's and numbers and it must be an inverse trigonometric function. Well, start off with your basic approaches. Well, in this case, if I let u equal x squared minus 2x, then du equals 2x minus 2 dx. If I factor out a 2 and divide, that will give me du over 2 equals x minus 1 dx, which is exactly what I have right here. So rather than trying to force in an inverse trigonometric functions, I now recognize that this is the same as 1/2 times the integral of, well, I'm going to write this as u to the negative 1/2 du. See, I can do this with just your basic techniques. I don't have to mess around trying to figure out or trying to force a derivative of an arcsecant or arc something. So this is just going to be equal to 1/2 times u to the 1/2 divided by 1/2. Obviously 1/2s cancel, but remember u was x squared minus 2x. So what that really gives me is x squared minus 2x to the 1/2, which is just a square root of that, plus c.